measured during spring water turnover increases, we can see also an increase in the intensity of algal blooms in the summer, which is indicated by chlorophyll concentration. However, in different lakes with the same phosphorus concentration, the intensity of the blooms can vary dramatically, even by an order of magnitude. This is dependent on the interplay between bottom-up and top-down processes in the ecosystem. Bottom-up processes are determined by the size of the nutrient load supplying the lake, and the top-down processes are related to biotic structure in the lake. Both of these processes influence the shape of the trophic pyramid in the lake. In the classic pyramid, the first level of producers has the highest biomass, and subsequent levels have respectively lower biomass. The bottom-up effect works in such a way that the greater the amount of nutrients, the proportionally greater the biomass at all levels of the pyramid. In turn, the top-down effect acts in such a way that an increase in biomass at a given level of the pyramid causes an increase in biomass, a decrease in biomass at the next lower level, but an increase in biomass 2 levels lower. Both of these effects occur simultaneously, resulting in a trophic pyramid shape that differs from the theoretical one. When the top-down effect is strong, which is associated with large number of predatory piscivorous fish that limit the abundance of zooplanktivorous, zooplankton-eating fish, we can observe a small algal biomass as algae are controlled by the large number of filter-feeding zooplankton. So we have good water quality. As the quantity of predatory fish decreases, the increasing number of zooplankton-eating fish reduces the abundance of filter-feeding zooplankton, and thus the bottom-up effect is getting stronger, resulting in an increase in algal biomass and a deterioration in water quality. We can illustrate these two scenarios as follows. On the left, we have a scenario with low quantity of predatory fish and with poor water quality. On the right side, we have scenario with high numbers of predators and with good water quality. Returning to the aerial graph, we can therefore conclude that in lakes with large algal blooms dominates the bottom-up effect, while in lakes with low water dominates, where clear water dominates, the top-down effect is well pronounced. So, if the structure of fish community affects water quality, we can take measures to shape that structure accordingly. Indeed, the relationships shown on previous slides were the basis for practices called biomanipulation. The aim of biomanipulation is to reduce algal biomass and thus improve water quality by changing fish community composition. We have two classical methods of biomanipulation. First one depends on controlling or on seining of zooplanktivorous fish, which results in the increase of zooplankton biomass. Second one depends on stocking of predatory fish. But I would like to present in more details a method which is feasible in dammed reservoirs and depends on reducing the abundance of juvenile zooplanktivorous fish by water level manipulation. We called it as hydrobiomanipulaltion. Juvenile fish, also called as fry fish, due to their need to eat small prey, are in many ecosystems the main consumers of zooplankton. This is the case, among others, in Sulejev reservoir, which we have studied for many years. What is the relationship between the water level in the reservoir and the abundance of fry fish? Many dominant fish species spawn in shallow water, laying eggs on submerged plants. At high water level, the availability of such spawning substrates is high, so spawning success is high. When the water level is stable, there are a lot of fry in the reservoir, which quickly reduce the abundance of zooplankton, promoting algal blooms. Lowering the water level after spawning expose some of the eggs, causing them to dry out, thus reducing the abundance of fry. Again, we have two scenarios. One on the left, we have low fry density due to low water level, due to hydromanipulation, and this, in this case, is promoting good water quality. And on the right, we have high abundance of fish fry after spawning due to the stable water level, and this results in poor water quality. It should be noted that presented methods of biomanipulation are effective in lakes located in temperate zone, particularly those with low level of eutrophication. It appears that in the tropics and subtropic lakes, these methods are less effective. The reason for poor biomanipulation efficiency in these lakes are different characteristics of tropical lakes. What are the main differences? Let's compare the zooplankton in tropical lakes. First of all, we have fewer zooplankton species. We have lack of typical pelagic zooplankton. We have smaller zooplankton concerning the size and lower biomass of zooplankton. This is because of continuous predatory pressure. Daphnia are the main filtrators in temperate lakes. occurs sporadically and do not control algal biomass. Generally, biomass ratio zooplankton to phytoplankton is low. What about fish? Looking at fish community in tropical lakes, we can see much higher diversity of fish species comparing with temperate lakes. Moreover, adult fish can many species of adult fish can forage on zooplankton obligatorily. There are many clupate species, for instance, in Africa, around 20 species, which are obligatorily zooplanktivorous. Next feature of tropical lakes is high temperature, so food demands for fish are much higher. Many tropical fish can breed more or less continuously, so they are all over the year juvenile fish consuming zooplankton. So generally, biomanipulation is not an effective method of ecosystem restoration in tropical lakes because top-down effects are very weak due to low filtering zooplankton diversity and biomass. Therefore, other solutions affecting zooplankton biomass are being tested in tropical lakes. For instance, in Asia, shrimps are used as organisms that can play a role similar to daphnids in temperate lakes. But overall, we still have many problems to solve in order to improve the effectiveness of water quality measures. So there is plenty of room for action for new generations of scientists. So please join us. Thank you for your attention.
Thank you very much, Professor, for your interesting presentation.